Question number 3.1. Estimate shift. Example 3.1. First question. Estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area 1 into 10 to the power minus 7 meters square carrying a current of 1.5 amps. Assume that each copper atom contributes roughly one conduction electron. The density of copper is given and its atomic mass is also given. Then compare the drift speed obtained above with it with the thermal speed of copper atoms and speed of propagation of electric field along the conductor which causes the drift motion. First, we'll go for the first part. What are the given data? That is, current is given as 1.5 ampere, area of cross section 10 to the power minus 7 meters square, density of copper, that is mass per volume, 9 into 10 to the power 3 kg per meter cube. Atomic mass of copper is 63.5 U and charge of electron known to us, that is 1.6 into 10 to the power minus 19 coulomb. Drift current I equal to NEAVD, that is the relation between drift velocity and current. Here, N is number of electrons per unit volume. E charge, area, A, drift velocity, VD. Okay. We are not, N value is not given directly. First step, we'll go for N. N means what? Number of electrons per unit volume. Let us take number of electrons as capital N. So N per volume. But density of copper is given as 9 into 10 to the power 3 kg per meter cube. What do you mean by this? That is 1 meter cube of copper. Suppose if you take a cube, length is 1 meter, cube of copper is having mass 9 into 10 to the power 3 kg. Okay, first we will find out number of moles. Number of moles, that is mu equal to mass by molar mass. Mass is given as 9 into 10 to the power 3 kg, convert into grams multiplied by 1000. 9 into 10 to the power 3 into 10 to the power 3 grams divided by molar mass. Molar mass is given as 63.5. So, if you substitute, you are getting 9 into 10 to the power 6 divided by 63.5. This is number of moles. Okay. Now, number of copper atoms in 1 meter cube. How many copper atoms are there in 1 meter cube? That is number of moles, that is mu, multiplied by with Na. What is Na? Avogadro number. 1 mole has Na number of molecules. Mu mole has how many molecules? So, that is 9 into 10 to the power 6 divided by 63.5. This is number of moles. Multiplied with Avogadro number, you are getting total number of copper atoms in 1 meter cube. Okay. Number of conduction electrons, that is same as this one. 9 into 10 to the power 6. 63.5 multiplied by this. Number of atoms is same as number of electrons. Why? Because copper is monovalent. Each copper atom contributes 1 electron. These many atoms are there means these many electrons are there. So we got number of electrons per meter cube is, if you simplify, how much we got? 8.5 10 to the power 23 electrons per meter cube. We got number of electrons per unit volume. Now we'll proceed how to find the drift velocity. Drift velocity equal to I by NEA. I is given directly. What is I value? I value is 1.5 divided by N. N we got 8.5 10 to the power 28 multiplied with charge of electron into area. How much? Area is 1 into 10 to the power minus 7. If you simplify, you are getting the answer 1.1 into 10 to the power minus 3 meter per second. So, we completed the first part of the question. Drift velocity of electron is found to be nearly 10 to the power minus 3 meter per second. Now, we'll go for the second part of the question. That is, compare the drift speed obtained above, that is 10 to the power minus 3 we got, right? With the thermal speed of copper atoms at ordinary temperature. What is the ordinary temperature here? Ordinary temperature is 300 Kelvin. This you have to keep in the mind. Boltzmann constant value 1.38 into 10 to the power minus 23 joule per Kelvin. Okay, so Boltzmann constant value is given. Temperature, room temperature is given. M is mass of the electron. So in the last class 11, you have studied this formula. Vrms equal to root of 3 kT by m. What is thermal speed? It is the random speed of atom due to temperature. So Vrms equal to root of 3 kT by m. Okay. Now we want m. M is mass of the atom. Mass of one atom, that is capital M, molar mass divided by Avogadro number gives mass of one atom. Molar mass is 63.5. This is in terms of grams, right? So I'm multiplying with 10 to the power minus 3. I'm converting into kg. 10 to the power minus 3 divided by Avogadro number. So Avogadro number, we are getting the answer mass in terms of kg. I repeat, capital M molar mass is 63.5 grams. So I converted into kg by multiplied by 10 to the power minus 3 divided by Avogadro number. We got mass of one atom. Now we'll start substituting. Vrms equal to root of 3. Boltzmann constant value 1.38 10 to the power minus 23. Room temperature is 300 Kelvin divided by m, mass of one atom is 1.05 10 to the power minus 25. So if you simplify, nearly you are getting 1.18 10 to the power 5 or nearly 3.4 into 10 to the power 2. That is nearly 340 meter per second. Now we have to compare. V thermal is, suppose if you are leaving approximately 10 to the power 2. Okay. Comparison. Part B, compare the drift speed obtained above with the thermal speed of copper. Thermal speed we got it. So V thermal divided by V drift is asked. V thermal 10 to the power 2. V drift in the previous portion we got 1.1 10 to the power minus 3. Therefore, 10 to the power 2 divided by 10 to the power minus 3. Nearly you are getting 10 to the power 5. 1.1 rough. Nearly you can take it as 1. Therefore, thermal speed is 10 to the power 5 times that of the drift speed. Thermal speed is greater. Okay. I hope it is clear. We'll go for the third part now. Last part. Compare the drift speed with the speed of propagation of electric field along the conductor which causes the drift motion. Okay. Now here we have to compare the drift speed with the speed of propagation of electric field. What is the speed in the question? Speed of propagation of electric field is not mentioned. It is almost equal to velocity of light in the medium of air. I repeat, speed of propagation of electric field is nearly 3 into 10 to the power 8 meter per second. Drift velocity, how much we got? First part, 1.1 10 to the power minus 3. Now, speed of propagation in the electric field to drift velocity ratio is asked, right? So this is almost equal to velocity of light in the medium of air. 3 into 10 to the power 8 divided by drift is 10 to the power minus 3. 3 divided by 1.1, you are getting 2.7. 10 to the power 8 by 10 to the power minus 3, 10 to the power 11. So, V in the field is 2.727 into 10 to the power 11 times that of the drift speed. Drift speed is how much? 10 to the power minus 3. The ratio you are getting this much. So, the electric field propagation is approximately 2.7 into 10 to the power 11 times that of the drift speed. I hope it is clear.